Okay, let us now discuss about what is meant by a linear, quadratic and cubic polynomial.
So now we have got different degrees. According to these degrees, the polynomial are classified. The polynomial are, okay, so I will write it here. We have to make a note that the polynomials are classified according to the degree. So how it is classified? If it is having a degree 1, so how it is classified? If it is having degree 1, it is called as a linear polynomial. Linear polynomial. Okay. If it is having a degree 2, then it is called as a quadratic polynomial. If it is having a degree 3, if the degree is 3, then it is called as a cubic polynomial. It is called as a cubic polynomial. Okay. Okay. So now what is 4x plus 1? The 4x plus 1 that is present here. Whether this is a linear, quadratic or cubic polynomial, this is a linear polynomial. Okay. And then the second one, y cube minus 2y square plus 1. What about this? This is a cubic polynomial. Okay. Similarly, the third example which we took, 2y square plus 3u minus 5. This is a quadratic polynomial. Fine. Okay. Okay. Now we will discuss about the general form, how a polynomial will look in a generic way. So that is the general form of a polynomial. General form of a polynomial. So for example, we had example 4x plus 1. So this is a linear polynomial, right? This is a linear polynomial. Okay. So let us try to write out some more examples of linear polynomial. Say I can write an example, say 2y minus 3. So this is also a linear polynomial. So why it is a linear polynomial? Because the power is, because the degree is 1. Which is the variable here? Y is the variable. And what is the degree of y? The y is having a degree of 1. So 1 is the degree. And hence this is a linear polynomial. Okay. So now let us write one more example of linear polynomial. Say minus 4u plus 2. Okay. So whether this is a linear polynomial? Yes, it is a linear polynomial. This is also a linear polynomial. Even though it is having a negative coefficient minus 4, the degree of u, what is the degree it has? U is the variable here, and the degree of u is 1 is the degree of u. So, and hence it is a linear polynomial only. So, when we observe these three examples, all these three examples, what we can able to conclude? If we observe all these three examples, we can able to conclude that it is having a general form. The polynomial, these three polynomials, that is the linear polynomials, have a general form. Say I can write the general form as ax plus b. So say p of x. So what is b here? B here, it is nothing but the constant term. B is the constant term, h is the variable, and a is the coefficient of h. Okay. So ax plus b, very important, ax plus b, this is the general form of a linear polynomial. It is the general form of a linear polynomial. Similarly, we can write the general form of quadratic polynomial also. Okay. So the general form of quadratic polynomial is, say p of x is equal to ax square plus bx plus c. So here c is the constant term, h is the variable, b is the coefficient of h square, this is also a variable, this is also the same variable, and a is the coefficient of h square. Okay. So what is the degree it has? It has a degree of 2. The highest degree is 2 here. So this is the general form of expressing a quadratic polynomial. This is the general form of expressing a quadratic polynomial. Similarly, so this is for the linear polynomial. Similarly, I can write the general form of a cubic polynomial also. So similarly, I can write the polynomial of a general form of a cubic polynomial also. Say p of x is equal to ax cube. Here the degree is 3. The highest degree is 3 plus bx square plus cx plus d. Okay. So here d is the constant term, the x square and h cube, these are the variables, and a is the coefficient of h cube, b is the coefficient of h square, c is the coefficient of x. The highest degree here is 3, and hence this is the cubic polynomial. This is the general form of cubic polynomial. Okay, fine. So let us summarize about the general form. So the general form of linear polynomial is ax plus b. Okay, the general form of a, so the general form of a quadratic polynomial is ax square plus bx plus c. Similarly, the general form of a cubic polynomial is ax cube plus bh square plus cx plus d. So one of the important note which we have to understand is the degree of the polynomial, that is the highest power. The degree of the polynomial, it is a set of natural numbers, set of natural numbers. Okay, so the degree of a polynomial is the set of natural numbers. So it is, the degree is 1, 2, 3, so on and so forth up to infinity. Okay, that means the degree cannot be 1 by 2, 2 by 3, or any decimal 0.533. These type of decimals or these type of fractions are not allowed or not considered as degree. The degree of a polynomial can only be the set of natural numbers. It can only be the set of natural numbers. It can be like, say, 1, 2, 3, 4, 5, 6 up to 100,000 up to infinite. But this cannot be accepted as a degree. 1 by 2, 2 by 3, 0.533 cannot be accepted. Okay, it cannot be accepted as degree of a polynomial. Okay, so we have to understand this note perfectly. Okay, now there is a question which cannot be accepted as a polynomial, which is not a polynomial. So because I told you that the degree can be a set of natural numbers, that is 1, 2, 3, 4 up to infinity only. Only these can be considered as a polynomial. Now it arises a question which cannot be considered as a polynomial. Okay, so let us understand which cannot be accepted as a polynomial by looking at some examples. So example, say 1 by x minus 5. This is not a polynomial. This is not a polynomial. The reason is, what is the power of x? What is the degree of x? The degree of x is 1, but it is in the denominator. So this cannot be accepted as a polynomial. Okay, so let us take one more. Let us look at one more example. Say 1 by m square minus 3m plus 1. This is also, it is not a polynomial, because the degree, it is in the numerator, the variables are in the numerator. Okay, this cannot be accepted as a polynomial. Fractions cannot be accepted as a polynomial. Okay, and let us look at one more example. X power 2 by 3 plus 1. This is also, it is also not a polynomial. Okay, to write it generally, which cannot be accepted as a polynomial: fractions. Okay, decimals. Okay, then negative powers. These three things cannot be considered as a polynomial. Okay, so the fraction, in the sense, it is with respect to the term it is with respect to the variable. Okay, so here even though in this example we can see x power 2 by 3, 2 by 3 is a fraction and hence this is not a polynomial. Here 1 by m square minus 3m plus 1, it is in the denominator, so it cannot be accepted as a polynomial. Let me give you a question. Some questions. So now let me give some questions so that you can able to answer and tell us and tell me which is a polynomial and which is not a polynomial. Okay, the first one. Okay, so you have to find, okay, find which is a polynomial, okay, which is a polynomial and which is not a, of course, which is not a polynomial. Okay, fine. So square root of 3x plus 5. Okay, the second one is y plus root 3. Okay. The third one 2x square plus 3x minus 1 by 5. Fourth one u by 3 minus 2u square plus 5. Fifth one square root of 5 u square minus 2 by 3 u. Sixth one 2 minus h square. Seventh one is 1 by y square minus 5. Eighth one is y power 3 by 2 minus y square plus 5. Ninth one is square root of y root y minus 3. The last one 1 by y square plus 3y minus 1. So there are 10 problems. You can pause the video and try to answer which is a polynomial and which is not a polynomial. Okay. So the first one here. So when we take the decision which is a polynomial which is not a polynomial, we should look only at the variables. Only these three things, only it is considered as it is considered for the variables. These three things it is considered for only for the variables and it is not for the coefficients. So here x is the variable, and the degree of x is 1. It is not in numerator or denominator, everything is fine. Okay, square root of 3, that is the coefficient of x. Okay, but x does not have any fraction or decimal or negative powers. Okay, so this is a polynomial. Yes, it is a polynomial. Okay, similarly here root 3, that is the constant term, but we have to look only for the variables. Why? Okay, y does not have any fractions, any decimal or any negative power, so this is also, it is a polynomial. Okay, the third one 2h square plus 3h minus 1 by 5. The constant term is minus 1 by 5, it is a fraction, that is okay, but for the variables there is no fraction, decimal or negative power, so this is also, it is a polynomial. Okay, the next one. So what is the coefficient of u? The coefficient of u is 1 by 3. Here the coefficient of u is 1 by 3 is the coefficient of u. And what is the coefficient of u square? That is minus 2. So u and minus 2, u and u square, these two things does not have any fraction, decimal or negative powers. So this is also, it is a polynomial. Okay. Then here, so why square root, the square root of 5, the square root, it is only for 5, it is not for the power, it is not for the variable. So this is also, it is a polynomial only. Okay, here, so this is also a polynomial because the power, the variable does not have any fraction, decimal and negative powers. Fine. So now here, even though the variable is having a degree of 2, okay, but it is in a denominator, so this is not a polynomial. Okay, here the variable is having a degree of 3 by 2, here it is having 2, whereas here it is having a degree of 3 by 2, which cannot be accepted because it is having fractions, the variables contains fractions. Okay, so it is not a polynomial. Here also the variable is under a square root, so it is not a polynomial. Here it is a fraction, so it is not a polynomial.